Alright, 6.3, day number 1 through 3, volume of discs, washers, and cross sections. Today in this video, my main purpose will be to meet goal number 1, to talk about the volume using discs. Okay, so let's take, for example, a cylinder. The volume of a cylinder is pi r squared, which finds us the area of this base, times the height, which is this length here. Alright, now what we can do using calculus is we can call this pi r squared our area function and our height dx. And if we integrate, for example, from, let's say, 0 to, I don't know, let's say the height is 4, when we put those upper and lower limits on that, we can then find our volume. So let's talk about what dx actually looks like. So let's say we had a small disk, right? It looked kind of like this. It's not well done, but decent. This length right here, the width of that disk, is dx. And when we integrate, we're basically adding up all of and making dx as small as possible, so that we can add up all those volumes to get the cumulative volume of that shape. So how does this apply to functions? Well, if I have a function like, let's say, y equals 2x. Well, if I revolve that around the x-axis, I would end up getting this cone, this solid cone, and you can imagine that's the base of the cone, but I get these small discs, right, with a width of, dx, whatever we want to call it. And as we add up all these discs, we end up getting the volume of the revolution of f of x. So within the confines of that, right, I need to know what r is. Right? R has to be some specific value, otherwise I don't know. I mean, I can just work with variables all day, but if I don't know what r is, I've got a problem. Well, visually, r is this length here, which is just f of x at any given x. So to summarize, we could take the integral, if I wanted to find this volume here of this example, I could take the integral from 0 to, let's say, x equals 3 of pi times r squared. R is f of x, so I would have 2x squared dx, and that would find me the volume of that solid. Okay, so some steps to finding the volume of a solid is to sketch and find the typical cross section, find an area formula. Area formula is, so your cross section in this example up here would be a triangle. And if I were to sketch out from 0 to 3, I'd have a cross section of a triangle, and I'd be rotating that around the x-axis. So that's my cross section. Then I'd find an area formula. Your area formula will always be pi times f of x squared. And so it'll be f of x squared, not pi squared as well. Find the limits of integration. All right, so that'll just tell you what you're going to put at the lower limit and upper limit of your integral, and then you integrate. So let's consider the region bounded by the curve given there and the x-axis, as well as the line x equals 3. So let's sketch first. Sketching will be part of, like we set up here, step 1. Sketch the solid in the typical cross-section. All right, so negative x squared plus 4x. Well, let's do this so we know exactly where this ends up crossing the x-axis. I'd factor out an x, and I'd get negative x plus 4. So it looks like the graph of this would go through the origin, but we only want to go out to, we don't want to go out to 4, we only want to go out to, it looks like our limits of integration would be out to x equals 3, and we're told that there. So the sketch of this graph would look something like that. but then I want to revolve this cross section, right? So I'm going to take this function and revolve it around, it looks like the x-axis right here. Okay, so let's first figure out a formula for our area function, which we know is always pi times f of x squared. There might be some other stuff added in, but in this case, pretty simple around the x-axis, not going to be a big deal. So that'd be pi times the function negative x squared plus 4x quantity squared. Okay, find the limits of integration. We're going to go from 0 to 3. And I'm going to pull that pi out as a constant, leave the function in, and it'd be as easy as integrating that. All right. Most of the time, these questions will just require the use of a calculator. So at this point, I'll employ my calculator to help me find an answer. But before I do, let's look at what this, oh boy, that was bad, this volume of revolution would look like, right? So it ended up being a solid that looks, I don't know, kind of like a Hershey Kiss or something, okay? Where here are your disks. You can tell, right, that radius is getting larger until a certain point and then smaller. So it's forming this Hershey Kiss shape. I'm going to use my calculator to find that volume. But before I do, I can't forget to square my function, right? So square your function, and another common mistake is to forget to multiply by pi at the very end. Okay, so according to my calculator, I get a volume of approximately 96.133 units cubed. All right, let's try the following situation. Let's consider the region bounded by the hyperbola x equals 2 over y, and the line y equals 1, the line x equals 0. Okay, so let's sketch this first. Here's the line x equals 0, that's called the y-axis. Okay, the line y equals 0, let's also put in black. So that's y equals 0, that's the x-axis. Let's go our hyperbola. Okay, so the sketch of this graph would look like this. However, it looks like the stem, the second stem of the graph isn't necessary due to the fact that we're going to be revolving around the y-axis above the line y equals 1. Okay, so here I'm going to put y equals 1 here, and the line y equals 4 here. Okay, so the question is, what am I doing? What am I trying to, where's my cross section, I guess is the question I'm asking. Well, here's your cross section. It's between x equals 0, the function, y equals 1, and y equals 4. So in essence, we're going to revolve that around the y-axis, which is x equals 0, which means that this solid, if I tried to give it a kind of a third dimension feel, is going to kind of look like this. Okay, and now instead of dx, what are we going to have? We're going to have dy, because we're revolving this in terms of or around the y-axis. So my limits of integration, right? What's my lower limit for y? It's 1. Let me do that in green. My upper limit for y is 4. What is my area function? My area function, again, is going to be pi times the function. I'm going to go f of y squared, right? Because we want this in terms of y. So my area function would be pi times 2 over y squared. And then, of course, each of these widths would be dx. So I got little small widths for, dy. Right, so this should be dy. Okay, so we'd integrate from 1 to 4 of that. All right, let's go ahead and calculate on the side. All right, my calculator is giving me a volume of approximately 9.424 units cubed. All right, that's the disk method. All right, in terms of x or y, dependent on the situation. And you just go ahead and use Math 9. Math 9 is your friend on these problems. All right, see you in day 2, washer method.